This is assignment number 7, physical base rendering. We use the Cook-Torrance BRDF bidirectional reflective distribution function. The assignment displays multiple spheres, and we get to change some of the texture attributes in the rendering model. As we can see, all the spheres are metallic by default. The top row has the albedo texture map as defined as gold. The second row is aluminum, third row is copper, bottom row is iron. We also adjust the roughness based on the column. As we can see, the first column is shiny and metallic, roughness is 0. As we move to the right, we increase the roughness. The fourth column, the column all the way to the right, the roughness is equal to 1. As with previous assignments, we use the rotational camera through the keyboard. We can rotate the entire model and appreciate the environment map. We can see all the sides. We can actually also move the camera up and then move it down. This constitutes assignment number 7, physical base rendering. Thank you. This is the enhanced version for assignment number 7. We get to load 3D models. In this case, we loaded the Happy Buddha through the ASIMP library. We also get to expose some of the parameters through that window on the top left side through the IMGUI library. As we can see, we have two models, and the first attribute or parameter that we've exposed is the animate models. If we click this, the models get to spin on the y-axis, and we can carefully appreciate them from all the sides. We're going to stop it for now so it's not distracting. The next parameter is metallic. Right now they're fully metallic. The first one is gold, the next one is copper. If we start decreasing the metallic texture attribute, they lose that metallic property. At this point is kind of like a ceramic texture. If we go all the way to the left to 0, it's actually hard to see the properties. We're going to go back to metallic all the way to the right. The next attribute is the albedo texture map. By default, model 1 is gold. We can change that to aluminum, as we can see. Let's make the second one, we can go from copper to iron. Actually, aluminum and iron are somewhat similar, so we're gonna make the first model gold. As with previous assignments, we also have the rotational camera through the keyboard that we can rotate and see the environment map and actually the models as well. One of the nice features about the IMGUI, right now it's covering the model. We can move it out of the way or even reduce it, so it's not really obstructing the model. If we change the albedo back to copper, we can really appreciate it. It's a nice reddish color. Let's continue moving the models, and to end the video, we'll animate it. Thank you very much. This is assignment number 8, spectral rendering. This is the enhanced version. For this particular version, I was able to load many models to the grid. Also, I introduced a rotational camera that we control it with a mouse. It's much easier to hold it, and we actually can zoom in and out. This small sphere, white sphere, represents the light source. We can actually control it as well. And let's just give it one. We can see that the light source is all the way in the back. We're going to zoom in with our light source and get really close to the models. We can actually go down as well, and we're gonna try to go to the center, and let's get closer. And at this point, the whole scene is getting dark because they're losing their light source. If we keep going deeper, we will see that the light source is on the opposite side. So we can see it from the back. But let's actually bring the light source to the front again. Here, I also added a rotation for the models by pressing R. The models get to rotate. One column rotates clockwise, the other column rotates, alternates counterclockwise. If we get close to each model, we can appreciate the lights and the shadows. As you can see, each material property represents a different color from the Macbeth color checker palette. Let's bring the light source out of the scene towards the camera, and this represents the end of assignment number 7. Thank you.